every chemical reaction is a limiting reactant problem. Reactions continue for as long as there are reactants. If I have some generic equation like this, I will continue to get the products C and D for as long as there are A and B. As soon as one of these runs out, A or B, then there can be no more products because I've run out of one of my reactants. I guess an easier example would be making sandwiches. If I'm making peanut butter and jelly sandwiches, I need peanut butter plus jelly plus bread gives me one sandwich. Actually, I need 2 pieces of bread. As soon as one of these ingredients runs out, I can no longer have more sandwiches. So what a limiting reactant problem seeks to do is to figure out which one of these reactants or ingredients will run out first. And if I can figure out which one of these ingredients runs out first, then I can figure out how many products I will have or how many sandwiches I will get. So supposing I had enough peanut butter for 10 sandwiches, I had enough bread for 15 sandwiches, but I only had enough jelly for 8 sandwiches. The limiting reactant would be the jelly, and I would only be able to get 8 sandwiches. And it doesn't matter that I have more peanut butter or more bread because there would be nothing for those two things to react and give me a super delicious sandwich. So I would be limited to 8 sandwiches because of the jelly. The jelly would be the limiting reactant. So now that I have the main idea, let me do a problem. Nitrogen gas can be extracted from ammonia over solid copper 2 oxide at high temperatures. Other products are solid copper and water vapor. If 18.1 grams of NH3 is reacted with 90.4 grams of copper oxide, which is the limiting reactant and how many grams of nitrogen are formed? And here is the chemical equation. 2NH3 plus 3CuO gives N2 plus 3Cu plus 3H2O. Now the amount of NH2 that is going to be formed is going to be limited by one of these two things, unless they are perfectly equal, which will probably never happen ever. So what I'm going to have to do is figure out which of these two reactants will run out first. And however many moles that is, that's how I'm going to calculate how much nitrogen will be created. So the first thing I need to do is figure out how many moles of each of my reactants I have. I'll start with NH3. I have 18.1 grams. I need to figure out how many moles I have. Nitrogen is 14.01 grams a mole. Hydrogen is 1.01 grams a mole. Times 3. Now I total these up for the molar mass of NH3, and this gives me 17.04. Now that I know the molar mass of ammonia, I need to figure out how many moles I have. .1 grams, I have 17.04 grams per 1 mole. And I've calculated all this out ahead of time to save time. This is 1.06 moles. of NH3. So now that I have the moles of NH3, I need to find out the moles of my other reactant, which is copper oxide. Copper has a molar mass of 63.55 grams. Oxygen has 15.99 grams. And there's one of each, so this is just a very simple addition problem. This will be 79.54 grams a mole. And there were 90.5, or is it 90.4? 90.4 grams of copper oxide. Now I have its molar mass. Which means there is 1.14 moles of copper oxide. Now I have the moles of both reactants. However, it does not stop there. If this was an example like the generic equation I gave earlier, where 1 mole of A reacts with 1 mole of B to give C and D, where these react in a 1-to-1 manner, in this equation they do not react 1-to-1. 2 NH3s are required for 3 copper oxides. So if I had an equal amount of NH3 and copper oxide, supposing I had, say, 10 moles and 10 moles, copper would be my limiting reactant because it requires 3 for every 2 of NH3, so this would run out first. However, in this example, I have more copper oxide than I do ammonia. So what I need to do is figure out which one of these will run out first. And the easiest way is just to take one of these, either NH3 or copper, and figure out how much it would take to react of the other substance. So if I pick NH3, I want to figure out how much copper it would require to completely react all of this ammonia. And if I pick copper, I want to figure out how much NH3 it would take to completely react 1.14 moles of copper oxide. And once I figure out that amount, if that amount, say I pick copper oxide, and I figure out how much ammonia it would take to react all of this, if that amount is greater than the amount present here, then copper is the limiting reactant. If it's less than this amount, then copper is in excess, and then NH3 is the limiting reactant. This will be easier to explain once I do it. Let me just go ahead and do it. So I'll pick copper. I'm going to figure out how much copper, or I'm going to pick copper. I'm going to figure out how much NH3 is required to react all of this copper. So I have 1.14 moles of copper oxide. And it takes 3 moles of copper oxide to react with 2 moles of NH3. So what this is going to tell me is how much NH3 is going to be needed to react all of this, to make this completely gone. And that number is, where did I calculate that? Oh, here we go. 0.807 moles of NH3. So in order to completely use up all of this copper, I would need 0.807 moles of NH3. And now what I do is I compare this amount to the amount of NH3 I have. It takes 0.807 1.07 moles of NH3 to completely react 1.14 moles of copper oxide. But I have 1.06 moles of NH3. So that means all of this would be reacted with just 0.807, but I have 1.06, which means I'm going to have excess NH3, which means that copper is my limiting reactant. I could have done it the other way. I could have found out how much copper would have been required to react all of this, and it would have been some amount that is more than 1.14. So it does not matter which one of these is picked. So I know that the limiting reactant is copper, which means that 1.14 moles of copper is all the amount of product I'm going to get. So what I'm going to do is compare the ratio of copper to nitrogen now. So to figure out how much nitrogen I can get, I have 1.14 moles of copper oxide. All of this is going to be used up. I don't really care how much ammonia there is, and I don't really care about copper and water right now. All I care about is finding the grams of nitrogen. So all of this copper is going to react, and then the reaction will stop. So I need to figure out how many moles of nitrogen I can get for this copper. So I need to figure out the mole-to-mole ratio. So for 3 moles of copper oxide, I get 1 mole of nitrogen gas. And this is going to give me the total amount of nitrogen product in moles. And that is equal to 0.38. Moles of N2. Now to figure out the grams, all I do is convert nitrogen back from moles to grams. So figure out the molar mass. Nitrogen is equal to 14.01 grams a mole, and there are 2. So this is going to be 28.02. So that's the molar mass of N2. Now I convert. And this is 10.6 grams. And this is the final answer. So what I did for the limiting reactant was I treated it like a regular stoichiometry problem. However, I had to figure out which one of these reactants would run out first, because as soon as one of these runs out, the reaction discontinues. It cannot continue anymore because one of the required reactants has run out. So once I figure out how many moles will react and which one of those is the limiting reactant, then I can figure out what will be the maximum amount of product I can get from those two amounts. And then I can figure out all of the products, or I can figure out just one. If I wanted to figure out copper, I could have done that as well. It would have been 3 moles of CuO to 3 moles of Cu, and then I would have figured out how many moles that is, and then I would have converted it into grams. And same thing with water. But that is the only difference really between limiting reactant problems and regular stoichiometry problems. It's just figuring out which reactant will run out first.